Today we're going to talk about section 3.4a, solving exponential and logarithmic equations. First, solving exponential equations. We're going to go through some specific examples, and in doing those examples we'll learn the techniques for solving exponential equations. The first example, e to the negative x squared equals e to the negative 3x minus 4. And right away you'll probably realize that since we're raising e to a power on both sides, then we can simply set those exponents equal to each other. And we have negative x squared equals negative 3x minus 4. And then you can solve for x using techniques you learned in Algebra 1. 0 equals negative 3x minus 4 plus x squared. Then we will factor that, and I'm not going to go through the factoring right now. You should already know that. Take a moment to factor the expression and come up with the solutions. Pause the video and then resume when you have your answers. And you should have come up with these answers: x equals negative 1 or 4. Another example, 3 times 2 to the x equals 42. First we're going to divide both sides by 3. We end up with 2 to the x equals 14. And then we can use the inverse property of logarithms that we learned before. And so I'd like you to pause right now and attempt to get x by itself using that property. And then resume when you have at least a first step. So this is our first step. We're going to take the log of both sides, log base 2 to the x equals log base 2, 14. That will get x by itself, which is what we wanted. X equals log 14 divided by log 2. Now, why is it log 14 divided by log 2? That's simply the change of base formula. Since most calculators don't have a way of changing the base manually, you can just use the change of base formula to evaluate x, and you should end up with x equals 3.81. One-fifth to the x equals 125. Again, we're going to try to get x by itself. So pause the video, set it up, and then resume when you have your first step. You should have come up with this. Log base 1/5, 1/5 to the x equals log base 1/5, 125. And why do we do that? Because that allows us to get x by itself, and x equals log 125 divided by log 1/5 because of the change of base formula. And therefore, x equals negative 3. You can just do that on your calculator. X equals negative 3. 5 minus 3e to the x equals 2. First, we subtract 5 from both sides. And when we subtract 5 from both sides, we have negative 3e to the x equals negative 3. And from there you should be able to solve. For practice, pause the video, solve for x, and then resume when you have an answer for x. And you should have come up with x equals 0, since e to the 0 is 1. We're going to solve some more exponential equations now. E to the x plus 5 equals 60. Take a moment to solve this equation. And after you've tried to solve it yourself, pause the video now, try to solve it yourself, resume, and check your answers with what's projected on the screen. So you should have done this as your first step, e to the x equals 55. We simply subtract 5 from both sides. And now we want to get x by itself, so we take the ln of both sides, the natural log. ln e to the x equals ln 55. Therefore, x equals ln 55. And now you can just evaluate ln 55 on your calculator to get x equals 4.01. 2 times the quantity 3 to the 2t minus 5 minus 4 equals 11. This is a slightly challenging one. You can pause and try to do it on your own. Don't worry if you get stuck. Just don't spend too long on it. Just try to do it on your own, and then resume the video when you've completed it. So here we have our first step. We add 4 to both sides. And then we divide both sides by 2. And now we take the log base 3 of both sides because we want to get 2t minus 5 by itself. That's the reason we do this. Then we have 2t minus 5 equals log base 3, 7.5. Then we add 5 to both sides, so 2t equals log base 3, 7.5 plus 5. T equals 1/2 times the quantity log base 3, 7.5 plus 5. And t equals 3.42. Now, notice that the log base 3, 7.5, you can evaluate that on your calculator, but you need to use the change of base formula. And that would be log 7.5 divided by log 3. So anyway, you should end up with t equals 3.42. e to the 2x minus 4e to the x minus 5 equals 0. Now, this looks complicated, but actually it's simpler than it looks because we can factor, as we did in Algebra 1. We can factor. And if we factor, well, this is what we get. e to the x plus 1 times e to the x minus 5 equals 0. Now, if you multiply that with the FOIL method, you should see that you'll end up with just e to the 2x minus 4e to the x minus 5. So the factoring works. But the thing to learn with this example is that sometimes the approach is to start with factoring, so that you can just simply get e to the x instead of e to the 2x. Okay, so pause the video, solve for x, and then resume. And you should have gotten x equals 1.61. Now, notice that e to the x plus 1 is not going to have a solution, because if you set e to the x plus 1 equal to 0, you're going to get e to the x equals negative 1, and that obviously doesn't work. And you can prove that to yourself on your calculator, because if you take the natural log of negative 1, you get an error. However, the other factor, e to the x minus 5, that does work, because when you set that equal to 0, you get e to the x equals 5, and then when you take the natural log of 5, you end up with x equals 1.61. Here's another similar example. E to the 2x minus 7e to the x plus 12 equals 0. So your first approach should be to factor. Pause the video, factor, and then resume when you have it factored. This is the factored form, e to the x minus 4 times e to the x minus 3 equals 0. Then, using your Algebra 1 techniques, you simply set each of those factors equal to 0 and solve for x. And this is what you end up with, x equals 1.1 or x equals 1.39. Now, notice in this case that both factors do work, because e to the x minus 4, setting that equal to 0, will give me e to the x equals 4, and then ln 4 is a real number. And then looking at e to the x minus 3, when I set that equal to 0, I get e to the x equals 3, and then x equals ln 3, and ln 3 is also a real number. So we end up with two solutions this time. So before going on, make sure that you understand these examples. I didn't show you all the steps for the last two because you should know those by now. When you want to get x by itself, if you have e to the x, you simply take the ln of both sides. So in the last two examples of this screen, the ones that use factoring, I didn't show the steps, but you do have to do something similar to the first example on this screen, where we had that e to the x plus 5 equals 60 problem. When I end up with e to the x equals 55, I have to take the ln of both sides. And so you use a similar technique in the last two examples of this screen. Here's the classwork. Page 254. Copy these numbers down. And you can get a head start if you want to, but you will have time in class to work.